Hello, everyone. My name is Okaolua Iwashokun, and I'm your trainer on this course. It's an introductory course. We'll be learning about data analytics and then doing some introductory course on SQL and Python. Today is our first class on the training, and we'll be discussing on data analytics, looking at the various aspects of data analytics, demystifying the various buzzwords, and at some points we'll be having discussions. Feel free when it's discussion time to lend a voice, and then we'll all discuss about various domains that we all belong to. I'm going to be sharing my screen now. Hang on there and let's zoom into the course together. So here we go. Okay, so today being our first class, we'll be looking at various, the background of data analytics, the various applied use cases of data analytics in our domains, then the knowledge of data analytics, concepts, buzzwords, various data terminologies, and then we'll also be discussing as we go on. There'll be some discussion time. Great. So here is our outline for the training for today, the first lecture for today. Okay, great. So data analytics is founded on the concept of data, and data analytics is not new. People have been doing different things with data. Data has been in existence, and various career domains in data has also been in existence, using data in their various endeavors, right? So in the 19th century, some statisticians were working on data, and at some point, they decided they needed to get more understanding into data, and then decided to use some scientific methods into exploring data, right? So at that time, various concepts on data and data science started coming up in various naming conventions, like we had datalogy, we had data exploration, we had it called information science. These were just, different ways people have been trying to explore data. And in 21st century, as the growth of data became enormous and became more due to the advent of internet, due to the advent of more storage devices that could amass much more data, data became much more enormous, much more prominent. And then the concept of big data, started, coming to lamplight. And what does big data mean? Big data really is just, data explosion, data in large capacity, data generated at various, high trend, high speed. Collection of data become, much more important, unlike back in the 19th, 18th century, when people would, collect data in paper or scrolls and then destroy afterwards. But now data is, very key, and there are now protection for data, protection rules for data. Data is no longer getting destroyed as quickly as it was getting destroyed before, but instead data is beginning to accumulate more and more, and then this brought about the concept of big data. Now, also in the 21st century, the exchange of data between human agents became more, and it became, at seamless and increasingly enormous, because people were beginning to generate data almost at every second with the advent of social media, social technology, mobile phones. All over the world, millions, billions of data is being generated per second. So I would say that big data is a large generation of data as a byproduct of various human to machine and human interaction. So big data is not just a buzzword, but is a concept which is the reality of the 21st century. It's a concept which is the reality of the world we live in now, because data is accumulating and accumulating, and data is not getting easily destroyed, and data is becoming, there are bigger and bigger storage for data as you go on. So what makes data big? What are the characteristics of the big data, or why do we call it big data? Right, the concept of big data became prominent when scientists and statisticians and mathematicians began to look at data as having certain characteristics of having very large volume. That's in size. Data is becoming, very, very enormous, very, very large collection of data, beyond what you can store in heaps of paper collection. So, storing of data in electronic devices and having several of data collection and information. Then data is also coming at, very high speed. So when you're looking at characteristics of data, these are key characteristics of big data. Data coming at very high speed, like I mentioned earlier, people generating data even like on the go. Then data having, coming in various varieties, having different types of data. Data now in form of images, in form of figures, in form of audios, different things that we would not classify as data before now, and now understood as data. As we go on today, we are going to look at the various types of data and the various categorizations of data. Then data now having value, right? Data now is becoming strategic to business decisions, strategic to profitability, strategic to competitive advantage. So data now is becoming an asset, or has become really an asset. Then the variability of data whose meaning is constantly changing. Data can take any form. So then the veracity of data. So these are various characteristics of big data. It's getting more and more. Scientists classify it by calling it V's of data. So we have the first 5 as the most important one, which is called the 5 V's of data. But even as we continue to study data, we understand that data is beginning to have more characteristics. Then looking now at the accuracy of data, that's the validity. Then saying also data can be vague, right? Big data can be vague. So vagueness, visibility, then the location of the data. So all of this, keep getting more and more, but these are various V's for classifying or characterizing big data. Now, data science is an interdisciplinary course, and it is premised on data. As the knowledge of data became more prominent, became more, scientists began to, come up with methods for dealing with big data and bringing up, insights and value from big data. So data science became a field, became a knowledge domain for many scientists, to start looking at various data. And why is it interdisciplinary? Because data is found in these various domains of the endeavors of life. So data science is not just a concept or a buzzword, is a domain field, it's a knowledge area, right? Which is interdisciplinary. Now, this knowledge area is premised on other key domain areas. Like we mentioned earlier that some statisticians were working with data and they needed to use more scientific methods to be able to understand the data. So statisticians, scientists, and computer scientists helped in bringing up softwares, algorithms that makes this knowledge of working with big data, that makes it, run faster and smoother. So interdisciplinary field of data science is premised on three core areas: scientific methods, statistics, and algorithms, right, to extract knowledge and insights from data. Now, data comes in various forms, like we talked about variability of data earlier. So data can come as structured, it can come as unstructured form of data. So for this definition, we are not just limiting to one particular form of data. So it's broadened to say that data, knowledge, insights can be extracted from both structural and unstructured data. And this definition is gotten from Wikipedia. There are various definitions for data science, but I chose this definition because it explains clearly what data science is, telling us that it's an interdisciplinary field, meaning that anybody can, gain the knowledge of working with their own data. And that's what this course is for, to help us in our various domains have a general, clear understanding of data analytics, and then have some soft technical skills on the understanding of data analytics as we move on. So data science is key, and data science is not only a concept, but a strategic domain area for every discipline, because this area is key now to many innovations, to many advantages, and they are like the most sought after now in various companies, in various establishments. People are trying to make sense, make meaning of their data that is being generated for various uses. So big data science is premised on big data. There would have been no data science if there were no big data. So as data continues to become enormous, it continues to become more strategic, it continues to become more, it continues to become an asset that drives innovation in technology space, in research, in economies, in businesses, and a list of endless things. So even for the fourth industrial revolution, for our domain and industry that we find ourselves in now, data science, big data are very key fields that one should be looking at. And not just looking at, but trying to understand it and also trying to apply it into your own field. Okay, so we'll be looking at some concepts and demystifying the buzzwords of these various concepts that we hear all around. And to start with, I want to first of all explain to us the precursor to data science. Remember, I said that data has not been new. Data has been collected ever since the history of man. But as data became, increasing, people started looking for ways to understand their data. And this started even as far as 19th century. The term data science was first mentioned at a conference going on within some statisticians trying to understand their data, like I mentioned earlier. Right, so data science is premised on what we call data analysis, analyzing your data, right? So analyzing your data is quite relevant. Analyzing your data also simply means trying to get understanding of the data using traditional methods. Now, these traditional methods could be like some simple, basic mathematical statistical methods that you are familiar with. And this was similar to what the statisticians and mathematicians in the community in 1962 were trying to achieve before they decided to go further and look for some other scientific methods to assist them in achieving that. So data analysis is a precursor to data science, and it's still relevant even in some business areas, in some organizations, in some enterprises. It comes sometimes in the name of data processing units, data driven discovery group or team, data exploration. Anything around data is very, very key and important to the process of data science. And all this work, hand in hand to the world of data science. So what we are just trying to explain here is data analysis is very important and also very, basic to getting to data analytics, which is in the space of data science. So this is a clear history of how data analysis transformed into data analytics. Right, remember the 1962 community I mentioned, and then the first name that was coined was datalogy. And the name data science was first coined in 1974. And as we move on and move on and move on, and then big data became more prominent, now we have things like artificial intelligence running on big data. In 2016, we had algorithms that could run on big data, learn on big data, and based on those learnings, be able to run data algorithms, data intelligence algorithms that could even beat human knowledge. So that's how analysis transformed into analytics. As we move on, we are going to see the essence of analysis in the world of data analytics. Without much ado, still again, data analytics is a multidisciplinary field, and it is for examining both quantitative and qualitative data. We're going to see the difference between qualitative and quantitative data as we move on. Then the whole life cycle of the data, from the historical data to the real-time data and actionable data, forms what we call data analytics today. So data analytics is encompassing, looking at learning from the historical data and real-time data, and then applying to predict, future data. Then data analytics is the journey from exploration to actionable insights used for business decisions today, which has made big data become an asset and for making strategic decisions. Then data analytics is complex function, but made up of three distinct elements, which are actionable insights, the algorithm, which are the technological tools for analyzing this data, and then domain expertise, right? This domain expertise is very key because the domain experts are the ones who have the data, who understand the data, and who can help in interpreting the insights. So you are very important to data analytics, irrespective of your own domain. So I would like us to look at our own domain, our field, and I'd like us to discuss various ways that data is being used to generate actionable insights, or what data is being generated in your domain, and we can discuss together how we think insights can be brought from this kind of domain, from this kind of data. An example is in the banking domain, we have transactional data. Now, this transactional data can be used to determine customers who would transact at a future time or not transact at that future time. And what we coin this to mean sometimes is customer's churn. So a customer would remain a customer, or by a certain future period, they will no longer transact, and then they will no longer be customers. So that's an interesting way of using big data. And when you study customers' buying pattern, you'll be able to determine that. Another example of actionable insights from big data can be in the area of agriculture, looking at various data from the agricultural farm yield and the weather and various features or characteristics that affect the yield of crops at a particular season. We could be able to, learn the data and also bring up insights to say, oh, this would be the yield at a future season. So these are ways that data is being used in the banking industry and also in agricultural industry. These ways are called like a forecasting way, looking into the future. It could also be an exploratory way, maybe looking at data and exploring the sales information in the data. Who are the top buying customers and what are they buying, so that you can make better business decisions to know the kind of products you should be positioning to your customers. So these are interesting ways that data can be applied in various domains. And I would just like to open the discussion floor now and let us discuss on 5 different domains, at least 5. So I would like at least 5 people to mention a domain and the data in that domain that can be used to generate a particular kind of insight. Thank you. Welcome back. Great. I hope we had a wonderful time and we have learned from our various discussions. I appreciate all those that have contributed to our discussions, and I would just like us to move on from there. So now we are looking at data analytics, and there are 4 main types of data analytics. I'm going to discuss the types of data analytics from increasing complexity. So the simplest type of data analytics is also like a form of analyzing your data. Remember, I told you data analytics is premised on data analysis. So the simplest form of data analytics, which is the descriptive analytics, is also similar or synonymous to your data analysis. So in a descriptive form of analytics, you are trying to analyze your data and trying to understand your data. So that is also a form of analysis. A difference or a major difference between analytics and analysis is the method being applied to doing them. Now, analysis could be much more primitive, using very traditional methods of trying to understand the data, maybe doing some addition and subtraction, some very, very primitive form of primitive traditional method of analyzing the data. But now we have some tools that have transformed from just being analysis tools to also being analytics tools. Excel tool is a very good example of that. Excel tool is not just an analysis tool, but it's also very good for basic or fairly increasingly form of data analytics. Yeah, so Excel can do a lot of descriptive analytics for you, and we are going to be looking at Excel today. We're going to be doing some demos on Excel today. So descriptive analytics is trying to understand your data, trying to discover some patterns or some knowledge or some key areas in your data. And statistics comes to the forefront in helping you to do this. Many functions, many mathematical functions and models in statistics have proven very, very useful in the area of descriptive, diagnostic, predictive analysis. Now, diagnostic analysis is a way of looking into your data and looking into your data with a view of diagnosing for a problem or for, diagnosing for a particular problem. So diagnosing is just similar to the world of medicine, trying to diagnose for a disease or for where the problem could be, or where the hiccup or where an anomaly could be. So diagnosing your data is also a form of analyzing the data, but with a view of understanding for an anomaly or for a problem or for an issue or for a different pattern from the norm in the pattern in your data. As we move on, we are going to see some various ways of understanding anomalies in our data. Sometimes this is called things like outlier, discovering outliers in your data and trying to understand them, or understanding something that is different from the norm in your data, different from the usual case in your data, and trying to give an insight to that. Another form of analytics is the predictive analytics, which is the most prominent part of analytics. Why? Because people are always keen to know what is unknown, right? And because predictive analytics helps in, estimating into the future. Yeah, it can't tell the future though. It will only give an estimate into the future. So because predictive analytics helps into estimating into the future with certain level of accuracy, people have, embraced predictive analytics even more and more. And then we have the prescriptive analysis. So the predictive analysis is a form of proactive analysis, predicting into the future even before the even without having the models or insights into doing this. So prescriptive is a different, form of data analytics as well. So these are various applied use cases of analytics. I'm sure we have discussed some of this in our last discussion. These are just other areas to, broaden our horizon into how analytics is being applied in various areas. Then we have, I would like to discuss on the concept of datatification. So datatification is another technological trend that is helping us in the areas of, transforming things that are not ordinarily classified as data into quantifiable data. And datatification has helped in the domain of, helping to understand and work with unstructured data. So the process of datifying things like objects, like subjects, things that are in the category of qualitative data into quantitative data is what we call datatification. So let's look at a few examples of datatification. And this has been very, very helpful in the field of artificial intelligence, right? Because things that would normally have not been easy to work with in data has now been datatified, right? And then it has now become easier for algorithms to be able to learn this, the insights in these forms of data, and then be able to give more interesting insights and information about them. So one form of datatification is datatification of music or audio. So music or audio, when spoken, comes in forms of, like I'm speaking to you now, comes in forms of various altitude of sounds. Now, these altitudes are like heights when plotted on a graph. So look at a graph sheet here. This is like a representation of a voice recording, and then comes in very, very minute heights of amplitude, right? So when this is expanded, you have it in form of this on the graph. So in datatifying it, the voice amplitude is represented in form of integers, and then this helps in putting it in a form that the computer algorithm can understand and then learn from and make and generate patterns from. And that's what artificial intelligence is about. As we move on in this training, we're going to discuss in detail what artificial intelligence is about and how it came to be and how it's being applied. Right. So another form of datafication is datafication of images. Right. So a flat image can be referred to a 2D image. And when you put a 2D flat image on a graph, it comes in form of this shape. And when you decide to, draw lines of columns and rows against the image, you could be able to quantify the image in that way. Now, in quantifying this image, these boxes of rows and columns are represented in forms of what we call pixels. Now, these pixels are then codified in the understanding of the level of light intensity or shades or some other information that can be used to extract unique features about each pixels. So each pixels, for instance, can be codified in this case in form of light intensity and represented in a form that the computer can understand. This is an interesting premise for computer vision. This is how computers are made to understand images. And then this is also very, very key in the area of data analytics for working with unstructured data like images. So for instance, in this case, you can use, you can represent the image of spoon with various floating numbers for different pixels. So a collection of the floating numbers across all the pixels drawn on the map represents a particular image. So different objects will come up with various pixel floating number collections. So this is an interesting way of datatifying images. Right. So another interesting way of datatifying unstructured data is in the area of text. And this is being applied also in numerous beautiful, wonderful ways. Like we hear of natural language processing, people, artificial intelligence working on text and being able to detect what is what detect errors or detect anomalies in text. All of these are premised on datafication of text. So in this case now, imagine an image as well being placed on a graph sheet that has the rows and columns on them. So these rows and columns as well can be datafied just like we did for the image that we saw earlier. Each of the rows and columns are representing pixels, and those pixels values are coded. And this is just for you to have an understanding of how this is done. There are various algorithms, when I say algorithms, I mean computer software. There are various computer softwares that are already doing this and are available for use that as a data analytics, one will just, know the right tools to use to achieve the insights that they are looking for. Another interesting domain area for datatification and data analytics is in the area of extracting filters or information from colored images. And colored images like the ones we have in scans from the medical field. So things like MRI scans can be datatified as well. The form of datatification for colored images comes in form of pixels as well, but now pixels in various layers of the basic colors for images. Like we can represent the colors for images as the key basic colors of red, green, blue. So the various intensity of the level of redness, of greenness, of blueness of the colors is being codified to form datatification for those images. And interestingly, these are beautiful ways that the world of artificial intelligence, is premised on and applying for things like, computer vision, text information extraction, and all the likes that we are, experiencing today and bringing about great innovations for us in the world of today. So we have seen interesting new ways of unstructured data in various fields. I would like us again to look at our fields, think of unstructured data that could exist in your field, and let's look at how you think analytics can be applied into it. An example I'll give again is in the banking industry. Computer vision can be applied to treating things like check information, right? Checks sometimes comes in, for paper checks, For paper checks, you could use computer vision to read the information on the checks and then be able to run the checks on the information read from the check, and then be able to classify the checks as maybe a check that should go through or a check that should bounce back, like a duty check. So that's an interesting way of analyzing unstructured data for deriving insights and driving innovation. So unstructured data is premised on helping to drive a lot of innovation. So I'd like you to now to mention, I like 5 domains, at least minimum of 5 domains, and various unstructured data in there and kind of innovations you think we can derive from the unstructured data in that domain. We are welcome back. Yeah, thank you. It was an interesting discussion. And to wrap up for today's class, for the first lecture, I'd like us to talk about machine learning and deep learning. These are some other concepts and buzzwords in the world of data analytics as well. We'll just look at the difference quickly and briefly, and then see how these things are being applied in the world around us, in the environment around us. So to start with machine learning is simply the ability for the computer to learn from data and then be able to replicate this same learning without human intervention. So that's why it's called learning. So it's not human learning, but machine learning. So understand the concept. It's machine in this case is like the computer. When we are talking of machines, we're looking at algorithms, softwares, right? So these things are being programmed, right, into computer softwares, and then they are being made to, on their own, to explicitly learn and explicitly carry out those instructions and then they continue to improve the accuracy. The algorithm continues to improve its accuracy as it continues to work with data. So machine learning is useful for developing the machine learning models that we use in the world of data analytics, and that's simply what it's all about. Now, there's now a higher class of machine learning, which is known as the deep learning. Now, deep learning, I would say, is like a multiple loop kind of machine learning. So deep learning is premised on the way the human brain is structured, meaning that it's a network of, insights or information going from various levels to another level on a very large network domain. So deep learning is a form of learning that is in many cycles, right? Learning and learning and learning on multiple layers, getting abstraction from the data on multiple layers, and extracting higher degree of features, higher degree of understanding, higher degree of insights from the data. And this way it imitates the way human gain experience, because we believe that humans as well improve with experience. So deep learning seems to be like a much more complex form of machine learning that helps a form of algorithm that is premised on the computer algorithm gaining much more insights from multiple layers of data abstraction on a very large network. And it's a kind of learning and relearning process. In deep learning, we call this mathematical process of learning and relearning a feed forward and a back propagation kind of process. So just picture deep learning as multiple layers of network of machine learning, of learning and learning and learning and learning until it comes to its level of saturation, and then we abstract that insight at that level of saturation. So that's about the major difference between machine learning and deep learning in clear layman's terms. And deep learning has been found very, very useful in driving innovations, in understanding unstructured data and working with unstructured data, and in bringing up very, very interesting insights that drive, the innovations that we see in the area of working with multiple levels of structured and unstructured data. Right. So we have various algorithms. Like I told you, machine learning, deep learning are basically algorithms, computer softwares that are programmed to run and make efficient the understanding of data. So we have various forms of algorithm, and then it has been classified into majorly the machine learning algorithms can be classified into majorly the type of algorithms that work with classifying or categorizing insights. So when you are working on insights that has to do with classifying or categorizing, for instance, you want to be able to determine if a customer would stop transacting or continue transacting, like we mentioned earlier, the case of customer churn, and you're looking at classification models, right? Or you want to determine if a transaction is fraudulent or not, then you're looking at classification models. Then if you're looking at things like that has to do with quantifying, or that has to do with figures. For instance, you as a sales analyst, you want to be able to predict the sales figure for the next month, the following month, and then be able to use that to prepare your sales reports and things like that. Then you're looking at numeric prediction and algorithm like the linear regression, regression tree are very useful for that, most especially the linear regression. Then, like I mentioned earlier, the deep learning algorithms is a fusion of classification and numeric kind of prediction that run on a very, very large network of learning and relearning the models towards bringing up deeper insights. So deep learning is synonymous to bringing up deep insights, right? So as an analytics, most times you're advised not to just jump into deep learning and all that, that you should start off with machine learning models. And then when you require deep insights or more insights, or if you're working with unstructured data, then you can get into the domain of deep learning. And deep learning is majorly of two types, or we have deep learning in majorly two areas, not just two types. We have in two areas, we have in computer vision, various application of deep learning in computer vision, understanding images, working with images, 2D images, 3D images, colored images. We hear of 3D printing now, we hear of virtual reality. All of these are premised on computer vision. Then we have natural language processing, things like Google Translator, things like your Grammarly or to proofreading tools and all that. They are premised on your natural language processing voice, processing text. All of this are a fusion of computing methods, scientific methods, and linguistics, domain coming into fusion to, increase the insights from unstructured form of data. Right, so this is a summary of the concepts we've discussed today. We've looked at big data. I'm sure you all have a clear understanding of what big data is now, the characteristics of big data, what makes big data significant. Then we've also looked at machine learning models. Machine learning are basically algorithms that are used to learn the insights or the working of data to generate insights from your data. Then you've also understood the concept of deep learning, data analytics, artificial intelligence as well. I've mentioned that at various points. Then we've talked about datatification, what it means, and how it translates, the impacts, the impacts of datification in the world of data analytics. And I've also talked about 4IR at some point, understanding that 4IR is the human development that we are in now, characterized by various extraordinary, technological advances that is premised on, all the innovations brought about from big data, from artificial intelligence, from data analytics, and as many buzzwords and concepts that you have out there. Then you have data science, data analytics. They are about in the same domain. They are all interdisciplinary field that is premised on, the main concepts of scientific methods, statistics, algorithms, towards extracting innovations, knowledge, insights, towards extracting knowledge and insights from data and creating, increasingly high, forms of innovations. So these are various data analytics softwares that are being used and are still in use in the world of data analytics. Like I mentioned to you, your Microsoft Excel is a data analysis tool and a very good data analytics tool as well, right? Because various descriptive analysis as well can be done using your Microsoft Excel, and they keep improving. And for any data expert, it's always good to have good understanding of Microsoft Excel and how to use it. Then you also have structured query language. The structured query language is a key language and a influential language in the world of data, because communicating with any form of structured data, is most times premised on some form of structured query language running, at the background. And structured query language can be seen as a unified form of, writing codes that data can understand and can generate information from the data. Another interesting tool that we also need to learn about is Power BI or Tableau or QuickView. Any of these three are very good, visualization tools that easily connect to your data source and helps you to, bring alive your data insights, plotting charts, graphs, helping you with some interesting infographics and the rest of that. Then for much more technical understanding of your data and applying some machine learning models and some deep learning models as well, you also need to understand how to use Python or R. And we have some other tools like the NoSQL and all that. But for a data analytics expert, what I advise is that you should be, familiar and good at using any of the first three analytics software on the list. Very important if you're working in the field of data analytics. Yeah, and then these are various forms of data, different ways that data can occur. We talked about quantitative and qualitative data. Quantitative is data in quantifiable form, like your integers, your floating numbers, data that can be measured. Qualitative is data that can be perceived, data in forms of voice, data in forms of information, like text and all that. Well, interestingly, we've looked at ways that data can be transformed from being qualitative to quantitative, right? So data, these are various, characteristics of big data, like we discussed earlier. Then data also can come as structured, unstructured, semi-structured data. Structured data comes in forms of rows and columns that can be easily accessed. So that's structured data. Unstructured data comes, in forms of things like images, text that can't be easily accessed, right, as raw data, right? And then you have semi-structured data that have a form of structure, but they are not easily understood by everyone. So things like your XML comes in forms of semi-structured data, or metadata of a document comes in form of semi-structured data. And you have the disparate and continuous data. As a data expert, you need to have clear understanding of these various data types, because sometimes you are faced with working with these various data types. The disparate data types is data at a discrete value, data that is that can be gotten at a particular value. For instance, your integers are discrete, but things like floating numbers that can take any form of value within a range are continuous data. For instance, between 0 and 1, you could have 0, 1, 0, 0, 1, 0, 0.1, and things like that. So floating numbers are categorized as continuous numbers. Then you have variable and constant data. Variable data is just a data location that can hold any form of data. So we say it's variable. Like in algebra, you have your x. X is a data, but can take any form of value. Then you have a constant data, which remains same value at any point in time. And you have the categorical data. Categorical data are data that can be classified, data that can be put into different buckets. And you have the non-categorical data, like your integers. They can be classified. They they are not into, they can take any data value within a range of numbers of integers or floating numbers. Then you have your nominal, ordinal, and interval data. Your nominal data is data in classes as well. And the difference between nominal and ordinal is data in labels or classes, but in ordered form, whereas the interval data is data at any interval. Then you have your vector or scalar data. Vector data is data at a point and has a direction. Scalar data is data at a position with no direction. So these are different forms of data that you may be working with as a data analytics expert, and it's important that you get familiar with their various differences and know how to work with them. Right. So this brings us to the end of our first class, where I'm happy you joined me at this class, and we'll see at the next class. Bye.